Bismillahirrahmanirrahim, and welcome to the online chemistry class. Tonight we are going to start with the past period practice from May-June 2023, paper 1, variant 2. Let's begin with the proceedings. If you can read the question, please.
Well, when chlorine gas is analyzed in a mass spectrometer, ions are detected. Which row is correct?
Cl35 positive ion. Now, you know very well the proton number of chlorine is 17. Am I right?
Yes, sir.
And this is an isotope of chlorine which has the relative isotopic mass 35 units, and positive charge shows that this chlorine atom has lost one electron to turn into Cl plus ion, right?
Right.
So this Cl positive ion is having 16 electrons. Am I right?
Yes, sir.
Okay. Now what they are saying, see all the options and try to figure out the answer, please. First,
Is
look
it
at,
D?
sorry, number of neutrons. They are asking, first of all, number of neutrons. So
Yeah.
you can easily get the number of neutron by this difference.
Yes, sir.
What
18 neutrons and
absolutely, absolutely. Now it means A and B cannot be the right option, right?
also,
So we are cancelling out, eliminating these two wrong options. Now focus on C and D and check with the electronic arrangement.
yes, sir.
So which of the electronic configuration is showing 16 electrons?
Let's see.
Absolutely right. C is the right option. I hope you got it, dear.
Yes, sir.
Let's move to the next one. Question number 2. Which species is a free radical? Do you know what do you mean by the word free radical?
One electron or something like free electron.
It has one unpaired electron in any of the orbital, right? Unpaired electron. It must have a single electron in any of the orbital, right?
Right.
So if we take the helium has electronic arrangement 1s2, 2s2, all paired electrons,
Yes, sir.
it cannot be a free radical. Fine.
Yes, sir.
What is the proton number of beryllium?
Checking, sir.
Please check with the proton number of beryllium. I think it is 4. The first element of group 2.
Yeah, it's 4.
4. Now it has 1 minus charge. It means it has gained one more electron.
Yes, sir.
So I'm writing the electronic configuration of this one. 1s2, then 2s2.
Is it B?
2p. Absolutely right. Now it is having an unpaired electron in the p orbital, right?
Yes, sir.
So it may be a probable answer. It may be a probable answer. Let's check C. C means O2 minus, it means 10 electrons. So 10 electrons mean simply we can write 2, 8, no unpaired electron, right?
Right.
Zinc has proton number 30. So it also has all paired electrons when you will be writing down the electronic configuration. So the correct answer is B. Am I right?
Yes, sir.
Let's move to the next one. Yes, please. Read the question number 3.
Which statement is correct? The first ionization energy of chlorine is more than the first ionization energy of argon.
Okay,
The
well,
second,
let's check this statement first of all. Chlorine comes before argon. They are in the
yes, sir.
same. They are in the same period, right?
Right.
And you know the first ionization energy increases in the period. So argon will be having greater first ionization energy as compared to chlorine, right?
Yes, sir.
And they are saying chlorine has the more first electron, first ionization energy. This is wrong.
Yes, sir.
Yes.
The second ionization energy of calcium is more than the second ionization energy of magnesium.
Wait, they are the elements of group 2, and calcium comes after magnesium, and down the group, ionization energy decreases.
Yes, sir.
So calcium will be having a lower value of second ionization energy as compared to the second ionization energy of magnesium, right?
Yes, sir.
So calcium is not having more second ionization energy than the second ionization energy of magnesium. So this is also a wrong option.
Right.
Let's check the option C.
The second ionization energy of sulfur is equal to the first ionization energy of phosphorus.
Do you think this is right or it is wrong?
Uh, Let me check where phosphorus is in the periodic table.
No, no, no. I'm telling you. Uh, phosphorus and then sulfur.
Right.
So sulfur comes after phosphorus.
It must have a greater energy.
Absolutely right. So that's it.
Right.
Ultimate option is D.
Yes, sir.
So let's move to the next part.
If 1 mole of hexane combusts in excess of oxygen, how many moles oh, how many moles of products are formed?
We need to write down the equation for the combustion of hexane. Hexane
Right.
is C6H14. It is undergoing combustion in excess of oxygen. So when excess of oxygen, we don't need to balance the oxygen, right? Because it is
Right.
excess. Because it is excess. Then it will be making carbon dioxide and water.
Right.
Now I need to balance only carbon and hydrogen. 6 carbon atoms, I am putting 6 over here. 14 hydrogen atom, I am putting 7 over here.
Right.
So
Sir,
total.
this equation for all of the organic compounds.
Now, sorry,
Is this the combustion equation for all the organic compounds? Is it like
almost, almost,
CO2?
almost every organic compound, almost every organic compound, when it undergoes complete combustion, it produces carbon dioxide and water, right?
Yes, sir. And how do we know it's complete combustion or not?
It will be told in the question. If they are saying excess of oxygen, it means 100% it is complete combustion.
Yes,
Am I right?
sir.
Got it?
Yes, sir.
And if they mean incomplete combustion, it will be mentioned in the question, incomplete combustion, right?
Yes, sir.
Okay. Now you can add the total moles of the products. 6 moles of carbon dioxide, 7 moles of water. How many total moles of the products?
13. C.
C is the right option. I hope you got it.
Yes, sir.
That's great. Let's move to the next one, please.
Right. Separate samples, each of mass 1 gram of the. Sorry, can you move up a bit? Yes, sir. Can you scroll up a little bit, please? Thank you. Separate samples, each of mass 1 gram of the compounds are listed are treated with an excess of dilute acid, which compound releases a large amount of CO2, the largest amount of CO2.
For that, first of all, please find out the relative molecular mass of every compound quickly. Calculate the MR of every compound and let me know about it.
Yes, sir.
I'm helping you. Calcium carbonate has MR 100. Sodium carbonate has MR 106. Now please check for the lithium carbonate.
Yes, sir. I got 73.8.
For lithium carbonate. Okay. Now do for the magnesium carbonate.
Okay.
Yes, please. Magnesium
84.3.
84.3.
3.
Okay. When 1 mole of calcium carbonate decomposes, I am writing the chemical equation for your help. When 1 mole of calcium carbonate decomposes,
Right.
it produces 1 mole of carbon dioxide, right?
Yes, sir.
They all are producing 1 mole of carbon dioxide, right?
Yes, sir.
So it means 100 gram of calcium carbonate is producing 44 gram of carbon dioxide. Am I right?
Yes, sir.
MR of carbon dioxide is 44. So 1 gram of calcium carbonate will be producing X grams of carbon dioxide.
Right.
So please divide the 44 with 100. It is 0.44, I think.
Yes, sir.
So 1 gram of calcium carbonate will produce 0.44 gram. Similarly, divide 44 with 73.8. 44 with 73.8.
0.59. So 0.6 basically.
0.59
59.
gram carbon dioxide. Do the same. Now divide 44 with 84.3.
Right. Um, 0.52.
0.5. This one,
Yes, sir. 44 divided by 106, that's
it is
0.41.
0.41. Acha,
So
wait.
0.5 and B.
Okay, wait. The technique, the shortest way to do this question, that 44 is divided by which, check that which denominator is smallest. This is the
Right.
smallest denominator, right?
Yes, sir.
So you don't need to do the other calculations.
Right.
I just did it for you to tell you the concept, but you don't need to undergo rest of the calculations when you have done with the two calculations. So you can see that 73.8 is the smallest denominator.
Right.
So numerator is same in all cases, 44. 44 is divided by smallest denominator. So it will produce the greatest answer. It will give you the greatest answer, right?
Yes, sir.
So you don't need to undergo these two calculations just to save your time. Fine.
Yes, sir.
This is the smart way of calculation. Okay. Let's move ahead. Yes, please. Please read this question.
Each statement about the Cl and O molecule is correct. Each molecule contains one pi bond and two sigma bonds.
This is
It
wrong.
is,
This is wrong because it has one pi bond.
yes, sir.
Yes.
It is a non-polar molecule. It
This
is
is
a
also
linear.
this is also wrong because they all have different electronegativities.
Yes, sir.
You know that oxygen has greater electronegativity, chlorine has greater electronegativity as compared to nitrogen, right?
Yes, sir.
So it's a polar molecule. Next.
It is a linear molecule.
No, it is not having linear molecule because nitrogen has a lone pair. It is the central atom. Central atom is nitrogen. It has a lone pair. It cannot be a linear molecule. So ultimate option is
nitrogen atom is sp2 hybridized.
And we know that whenever we have sp2 hybridization, it makes a double covalent bond in which we have one sigma bond and one pi bond. Am I right?
Yes, sir.
We have learned in sp2 hybridization. Should we move to the next one?
Yes, sir. Which statement about, okay, that which is that, okay.
Yes, please. Yes, Musa.
Right. Which row is correct? Molecules CO2 shape linear. Total number of pairs of electrons in the valence shell of the central atom. 2.
Okay, wait. Carbon dioxide is a linear molecule. Yes, this is right. But carbon is not having two pairs. Carbon has four pairs of electrons, right?
Yes. Yes, sir.
Let's check the boron trifluoride.
Triangle planar 3 number of pairs of electrons in the valence.
We have done with the boron trifluoride. Am I right?
Yes, sir.
It has three shared pair in the valence shell of boron. This is right. No lone pair. And when we have three shared pair, no lone pair, it's trigonal planar. Yes, it is trigonal planar. It is having three shared pairs in the valence shell of boron. You can see, right?
Sure.
So this is the right answer, right?
Yes, sir.
Any problem?
No, sir.
That's right. Let's move to the next one. Although it does not pertain with your syllabus of the test, because your test is based upon atomic structure and chemical bonding and structure. So this is from the states of matter, you know, the general gas equation. Would you
Yes,
like
sir.
to do this question, or should we move to the next one?
I don't mind doing it.
Sorry?
I don't mind doing it, so it's fine. We can do
Okay.
it.
Because it's better to focus on those topics for which you will be tested tomorrow, right?
Yeah, yeah, sure.
So let's do with some structured questions as well from chemical bonding and atomic structure.
Okay, sure.
Just wait for a while, please.
Sir, if
I hope you can see the screen now.
Yes, sir.
Okay. Now, this is the paper 2, variant 2 of the same paper for which we did with the paper 1. We just did with the paper 1 of May, June 23, the questions which are from the atomic structure and chemical bonding and structure, right?
Right.
Now, we will look into the paper 2, variant 2 of the May, June 2023, if it contains any question from atomic structure and periodic table, right? And sorry, atomic structure and chemical bonding and structure. Fine.
Yes, sir.
Let's see. Yes, please. Question number 1. Read the question number 1.
The melting point of some solids are shown in table 1.1. State the type of bonding present in magnesium and sodium chloride.
This is from bonding and structure.
Yes, sir. Bonding in magnesium is metallic bonding. Bonding in sodium chloride is
Metallic bonding, absolutely right. And in sodium chloride, sodium is a metal.
ionic.
Absolutely right. None other than ionic. You should not have any doubt in it, right?
Yes, sir.
So easy question to start with.
Yes, sir.
Let's move towards the next one, next part. What they are asking.
Explain the difference in the melting points of magnesium and sodium chloride.
And let's see how many marks. 1 mark.
Okay, magnesium has less charge. No, that's all right. Sir, I don't know the answer to that.
Okay. You can see that sodium chloride has a higher melting point, right?
Yes, sir.
As compared to magnesium. Now, in magnesium, we have metallic bonding. Metallic bonding means positive ions in the sea of electrons, right?
Yes, sir.
So, metallic bonding is the attraction, the electrostatic attraction, the electrostatic force of attraction between positive ions and the delocalized electrons, right?
Yes, sir.
Whereas ionic bonding is the electrostatic force of attraction between opposite ions. Am I right?
Yes, sir.
It means this electrostatic force of attraction between opposite ions is stronger than the electrostatic force of attraction between positive ions and delocalized electrons. Am I right?
Wait, I don't get it. Why though? So you
Okay.
just
Okay. Wait. If this species has a higher melting point, it means it has a strong bonding
yes, sir.
and it is a comparatively weaker bonding. Very simple. So
Right.
you can come up with the very simple response. Let me tell you, very simple response without referring any complicated thing. You can just write, beta, it's a 1 mark question. You can write that strong electrostatic force of attraction, force of attraction in sodium chloride. You can write down ionic bond in the bracket as well, no issue at all. As compared to metallic bond, as compared to metallic bond in magnesium. Am I right?
Yes, sir.
I got your confusion. You are thinking about the 2 plus charge of the magnesium ion, right?
Yes, sir.
Had it been any compound of magnesium, suppose magnesium oxide, then magnesium oxide would have this higher melting point as compared to sodium chloride. So they are asking about magnesium metal only, not the compound of magnesium.
Right.
I hope you got it.
Yes, sir. Yes, I do.
Your confusion is clear now.
Yes, sir.
Okay, let's move ahead.
Explain the difference in the melting points of phosphorus and sulfur in terms of structure and bonding.
It's a 2 mark question. It means here you need to refer structure, bonding, and type of intermolecular forces, and you need to compare the intermolecular forces between the two. And if they have provided you sulfur and phosphorus, yes, they have provided you with the data. Sulfur has 392 Kelvin, and phosphorus has 317. So obviously intermolecular forces, whatsoever they are, we will decide it. Intermolecular forces in sulfur, they are stronger as compared to phosphorus, right?
Right.
And you know both are non-metal, sulfur and phosphorus.
Yes, sir.
So certainly they will be having induced dipole forces, ID forces, or van der Waals
Right.
forces. Both are having van der Waals forces, right?
Yes, sir.
But sulfur is having stronger van der Waals forces
Right.
as compared to phosphorus.
Yes, sir.
We need to look into it. Why sulfur is having stronger van der Waals forces? This is to be explained over here. Let's see. First of all, we need to describe the bonding in both sulfur and phosphorus. Let's see. I'm going to sulfur has S8 structure. S8 structure means in one molecule of sulfur, 8 sulfur atoms are covalently bonded, right?
Yes, sir.
So S8 structure means one molecule, in one molecule, 8 sulfur atoms are covalently bonded. While phosphorus has P4 structure. It means one molecule of phosphorus contains 4 phosphorus atoms.
Right. Sir, do we need to remember these structures? Like
Yes, you need to. You need to.
only for these two, or are there more?
Yes, you need to. No, there's just a few one, not very much, right?
Right.
So one
So
molecule.
for silicon, sulfur, and phosphorus, right?
Yes. So one molecule of phosphorus has 4 phosphorus atoms covalently bonded, because you need to discuss both. Bonded, and both are simple molecules. You need to, both are simple molecules, right?
Yes, sir.
But which of the two is having more electrons? S8 or P4?
Oh, S8.
Yes, more electrons in S8 as compared to P4. So stronger van der Waals forces, right? Stronger induced dipole-dipole forces, ID forces in S8 as compared to P4. Am I right, beta?
Yes, sir. Yes, you are.
And you can see the response which I wrote.
Right.
That I discussed in detail structure and bonding in sulfur. Then I discussed structure and bonding in phosphorus. And then I explained that S8 structure has more electrons. And whenever we will be having more electrons in a molecule, it means stronger ID forces, stronger van der Waals forces. Is this okay?
Yes, sir.
You don't need to mention it. That's why it is having greater melting point. No, this is the command word. You don't need to discuss it. So,
Right.
or you can write it at the end, no problem at all. So sulfur has higher melting point. Sulfur has higher melting point as compared to phosphorus. I hope you got it, dear.
Yes, sir.
And I hope you are noting down the responses or taking the screenshots.
I'm writing them down.
So please note it down, because beta, when you see the marking scheme just provide you the short key points. You must
Yes, sir.
write elaborated responses, right?
Right.
Because those short key points are not for the learners. These short key points are for the examiners, basically, right?
Yes, sir.
Should I raise it?
Yeah, I'm done.
Okay. Let's move to the next point. Yes, please.
Explain the difference in the melting points of phosphorus and no, wait, that's not it. Define
Done.
electronegativity.
Very easy. The force of attraction of the nucleus of an atom on the shared pair in molecule, right?
Yes, sir.
Across the period, electronegativity increases, you know.
Yes, sir.
Reason, because atomic radii decreases
Right.
and more stronger electron attraction of the nuke with same shielding and more stronger attraction of the nucleus on the shared pair, right?
Right.
So you can do it easily. We have done it. Yes. Next one.
Name the strongest intermolecular force that exists between NH3 and
Very
liquid one.
easy, very easy. Whenever you have NH bond, which is the strongest
Hydrogen
intermolecular?
bond.
Yes, absolutely right. None other than hydrogen bonding. Am I right?
Yes, sir.
That's right. That's right. Let's move to the next part. What they say.
Draw a diagram to show the formation of the strongest intermolecular forces between two molecules of NH3 liquid.
We have done with the ample enough practice. Ample
Yes, sir.
enough practice, right?
Yes, sir.
No issue at all. No issue at all. And for that, you need to show all the lone pairs. You need to mention all the dipoles, right?
Yes, sir.
This is what is the requirement of examiner as per the CAI specifications. You need to show all the lone pairs, and
Yes, sir.
this is also told in the question, and all the permanent dipoles. And now you can make the hydrogen bond, you can show it with the dotted line with the lone pair of the adjacent ammonia molecule, no problem at all. Am I right?
Yes, sir.
And here you can make 3 hydrogen with the slightly positive charge. Again, it will give you full 2 marks because you shown all the permanent dipoles, you shown all the lone pairs, and you have mentioned the hydrogen bond with the dotted line between slightly positive hydrogen of one molecule and the lone pair of the adjacent molecule, right?
Yes, sir.
Any confusion?
No. The melting points of ice and ammonia are shown.
Right. Yes, please. Yes,
The
please.
melting point of ice and ammonia are shown in table 1.2. It suggests 2 reasons for the differences in the melting points of ice and ammonia.
Ice is water molecule solid, while
because actually no, never mind.
both are having hydrogen bonding. Am I right?
Yes, sir.
So now what is the difference?
Oh, water has more number of hydrogen bonds, I think, or strong.
Absolutely. Water has 2 hydrogen bonds per molecule,
Yes, sir.
while ammonia has 1 hydrogen bond per molecule, right?
Yes, sir.
That's it. Any confusion?
Oh, sir.
That's great. That's very nice. And we have done with the question number 1, which was fully based upon atomic structure and chemical bonding and structure. Now, this is not our topic. This is from the other chapter. We won't be having, no, there is no more question. So I hope you will be doing more questions from atomic structure and chemical bonding and structure. And please let me know if any problem arises, right?
Okay, perfect.
So see you tomorrow, inshallah ta'ala.